What is the science behind baseball's longest home runs? Imagine standing at the plate with a ball flying toward you at hundreds of miles per hour. The moment you swing, everything must align perfectly for that ball to soar over the fence. That's what makes the science behind the longest home runs so fascinating. It's a mix of physics, biomechanics, and player skill coming together in a split second. When a batter hits a home run that travels a great distance, it's mainly about two things: how the ball hits the bat and how it flies through the air. First, during the tiny moment when the bat makes contact with the ball, energy transfer is key. The bat and ball exchange energy in less than a millisecond. The speed of the bat at contact, called bat speed, is super important. The faster the bat moves, the more energy is transferred to the ball, making it leave the bat faster. The part of the bat that hits the ball best is called the sweet spot. When the ball hits this zone, vibrations are minimized, and maximum energy is transferred, resulting in higher exit velocity. Higher exit velocity means the ball leaves the bat faster and travels farther. Players work on their swing mechanics to increase bat speed, involving their legs, hips, torso, and arms working together smoothly. Once the ball is airborne, its flight depends on initial velocity, launch angle, spin, and environmental factors. The ideal launch angle for a long home run is usually between 25 and 35 degrees. When the bat hits the ball with backspin, it creates lift through what's called the Magnus effect. This lift helps the ball stay in the air longer, giving it more distance. Spin also affects how the ball moves through the air, making it more stable and less affected by wind. Environmental factors like altitude, temperature, and wind also play roles. At higher altitudes and warmer temperatures, the air is thinner, so the ball faces less air resistance and can travel farther. Wind can either help or hinder the ball's flight depending on its direction. Ballpark size and wind patterns can also influence how far a home run travels. From a statistical point of view, players with higher power metrics like slugging percentage and isolated power tend to hit longer home runs more often. But hitting a truly long home run is rare and requires perfect timing, a strong swing, and favorable conditions. The batter must quickly analyze the pitch and adjust their swing in a fraction of a second. Modern baseball stats track metrics like exit velocity, launch angle, and barrel percentage, how often the ball is hit in the ideal contact zone. Comparing these numbers across players helps us see how power hitting has evolved over time. Today's players often focus more on launch angle and exit velocity, which has led to more long home runs in recent years. In the end, the longest home runs happen because of a perfect mix: a high bat speed, hitting the ball at just the right spot on the bat, launching it at the right angle, and having the right spin, all under the right environmental conditions. These factors are measured and studied to help players improve their power and to understand how different eras of baseball produce varying home run numbers.